I built my dream productivity tool. Kind of. This is the Kronos, an almost wireless, somewhat programmable, and mostly 3D printed Hall effect macropad timer that I made completely from scratch. PCB, enclosure, software, pretty much everything. I'm big on productivity. Mind you, I probably spend 50% of my time on the internet watching videos on life hacks, new software and hardware to use that will save more of my time because, time is valuable. Out of all the techniques I've tried, there's one super simple tool that I found super helpful. A timer. Yes, a simple timer. If I want to get something done that I really don't want to do, like washing the dishes, organizing my room, even starting to work on a new project, I just set a 10-minute timer and focus on that one thing. Sometimes I kind of just start the timer and try finishing it before it goes off. It's kind of like doing one of those 80% speed runs, but in real life. Now, of course, I could use my phone, but I've been trying to avoid having my phone around when I'm working. So I decided to scratch my itch the only way I knew and make a dedicated timer myself. Now, I pondered on this idea for months until I set a 10-minute timer and just started cooking. 10 minutes turned into 30 minutes, 30 minutes turned into several hours. I didn't want to make any regular timer like you see in your granny's kitchen. I wanted something that would integrate well in my workflow. So I took timers and merged it with something I already use on a day-to-day basis, macropads, which is kind of like a keyboard, but instead of using it for general typing, they're more geared for turning shortcut combos into single key presses. Macropads are pretty useful themselves, but making one into a timer as well, bro, it's next level. Now I started with a simple sketch, an idea. I had a vision, man. Of course, I needed keys. I wanted a mini display on board, but to really make it stand out, I wanted a dedicated array of super bright LEDs. Now for all the features I wanted, a powerful microcontroller would also be on the requirements list. So I started pulling out the components, ESP32s, light strips, keyboard switches. But then I came to the realization, if I was going to make this as compact as I envisioned, I'd have to venture into unknown territory. PCB design. Not only would it allow me to make the Kronos into a super sleek and compact macropad with all the bells and whistles, I'd be learning a new skill that I've been looking to pick up ever since I found out you can make your own PCBs. So we set sail, man, onto SS YouTube. Goofy. Onto SS YouTube for a long journey to discover the way. So I spent the first couple of days binge watching YouTube to find the best tutorials on ESP32 based PCBs. I'm gonna go ahead and link some good ones that I found while I was deep diving into YouTube. I ended up deciding on using KiCad as my PCB design software of choice. Why? Because it's free. But nah, seriously, it's free, it's open source. They have a pretty cool Discord community that's open to any questions you might ask. So, I was taking full advantage. And man, I like KiCad so much, I actually made my own YouTube video on it. Now, eventually, I got started with my own project, laying out components, asking questions in Discord, rinse and repeat. I finally put together my first PCB for the Kronos macropad, ready to be manufactured. And I had to give the one and only PCBWay a try, especially with there being a PCBWay plugin available in KiCad. I one-click sent my PCB to PCBWay.com to get my first board manufactured. Now, while I was waiting for the board to arrive, I ordered all the components off of DigiKey and AliExpress for the project. When I got them in the mail, I was genuinely surprised. Seeing something you designed on the computer screen spawn in real life is a great feeling, especially when they come out as sharp as they do from PCBWay. Big thanks to PCBWay for making this project happen. All right, now I wanted the full PCB assembly experience, pasting and placing, and use a hot plate to get these itty bitty surface mount components soldered onto the board. Not gonna lie, this was a nerve-wracking experience. So if you opt in to get your PCBs manufactured at PCBWay, I wouldn't blame you, man. I wouldn't blame you. Now, once the board was cool, I plugged it into my computer and booted up VScode with Platformio and typed up a little quick test to see if my IO was working. We did it, everything worked. It's what I wanted to say. Not gonna lie, my pacing job was kind of whack. So when half my LEDs lit up, I wasn't surprised. I put the board back on the hot plate, then I realized I had an LED in the complete wrong direction. Life. Now mind you, this board was never meant to be used as a macropad really. It's really just a dev board to allow me to test my schematic and PCB design. So, we had a good foundation. So I quickly went back to the drawing board, booted up KiCad. Over the next couple of weeks, I cooked up something a little closer to my vision. Now this called for a whole redesign of my board, talking layout, adding components, removing components. This board included onboard Hall effect sensors sensors for the Hall effect keys, onboard Hall effect rotary encoders, rechargeable battery circuit, onboard display. We weren't playing around. No time was wasted. It was go time. Now, I made a big mistake. I decided to opt in for smaller 3535 adjustable RGB LEDs in my new design to have a more compact array of LEDs. But little did I know, I messed up somewhere in KiCad and assigned the wrong pin for the footprint, causing a minor short, and now the Kronos is a portable hand warmer. Life. I went ahead and cooked up hopefully my last PCB. I ditched the battery functionality, added another column of Hall effect sensors for my buttons, and added a regular button for just extra functionality. Why not? Now I also had to add 2 ADC converters for the Hall effect sensors. We went even smaller with the LED, like I learned my lesson. Now trust me, this time I triple checked. Now, while this board was off getting manufactured at PCBWay, I was confident this design was worth me making a case. So I started exporting a 3D render of my PCB, tossing it into my only CAD software that I have or know how to use, Solidworks. Now, using the PCB as reference made it infinitely easier to model. I designed a case to take advantage of heat set inserts, so my case would last longer without the unscrewing and screwing I'd have to do. And I ended up using a staple bearing to create a silky smooth Hall effect rotary encoder. Now, once the boards arrived, I quickly got the components on there, flashed a simple program to make sure they're working. And this time, we didn't create a portable heater. Now it was time to 3D print the enclosure. I exported the step files from my case, laid out the components in Orca Slicer, and sent it to my Bamboo Lab P1P. 2 plates, and 2 hours later, we had our first case. Now this is when things started to look a little bit more official. Now if you 3D print, you must know it takes a few go-arounds to get things fitting just right. Once I was satisfied with the rough fit and finish, I used a soldering iron to get heat set inserts into my 3D printed case. The design is quite simple, with screws attaching the PCB from the bottom of the case. And once the top plate is finessed into place, it can be screwed on with M2 screws through the bottom of the case. Now we finally plug in the mini OLED display, and now we have a fully assembled Kronos. The goals I have for functionality was quite simple: have a working macropad and have a working timer. Now to be honest, I underestimated the complexity of the code. Choice of components made this seemingly simple project a tad more complex. These Hall effect sensors, or magnetic sensors, don't have an on and off state, but rather output a signal depending on how close a magnetic field comes to the surface. Similar concept works with the rotary encoder. Now these might look like regular switches, but in this case, these are actually magnetic switches, Hall effect switches, and the magnets are built into the switch. The further down you press them, the higher or lower the output will be. Now this allows us to dynamically set where we want the switches to be activated in the software. Now I couldn't find any libraries that handle this exactly how I wanted to for my use case, so I cooked up something from scratch. Writing code for the Kronos was a multi-month process, as I would make some good progress, but often procrastinate on the main features. Now I won't go too crazy and try to explain the code to you guys. There's a lot to talk about, but what's important is that it works, with some caveats. 1. The Kronos does not need to be plugged into a computer you want to control. Matter of fact, you don't even need it to be in the same room. The Kronos communicates solely through Bluetooth, since I couldn't manage to get keyboard emulation working. 2, at this moment, it's required to recompile your code every single time you want to make a change to the Kronos, which is a little bit tedious, of course, and it makes it a little more difficult to experiment with different combinations and shortcuts. And 3, every single time the Kronos goes through a power cycle, it's required to recalibrate the Hall effect switches. Since there's variances between every single Hall effect sensor, it's required to do this process. Now I was planning to use the EEPROM to save these calibration values, but unfortunately, when I was doing some tests, for some reason I couldn't get it to work after a couple of times. I think I fried it, or I think I corrupted it or something. I'm not sure. Now designing the Kronos was the first time I created something that I could use on a day-to-day basis. You know, something that was actually useful, something that would actually enhance my life. Now there's many more features I like to add to the Kronos, like on-screen animations, more robust dynamic lighting for the ARGB LEDs to show how much time is left. But for now, this will do. If you guys have any projects that have been living in your mind rent-free and something's been holding you back from starting it, just set that 10-minute timer and just get started. I'm always interested in hearing what cool stuff people are creating, so feel free to drop a comment below telling us your project that you're working on right now. I appreciate you guys for watching the video.
Oh yeah, this is open source too. Don't worry guys, I got y'all. Check out the GitHub, all right? Peace.